Today's episode is sponsored by Influx Data, the most popular open source database for developers managing time series data. Visit them at influxdata.com.
Aerospace and defense manufacturing.
Machines and automation.
Additive manufacturing.
Smart manufacturing.
The global manufacturing economy.
Welcome to Advanced Manufacturing Now, the podcast for manufacturing professionals, powered by SME. From the design screen to the shop floor to final assembly, we drive the conversation about making manufacturing smarter by connecting people who are passionate about manufacturing.
Hello and welcome to Advanced Manufacturing Now, the podcast for manufacturing professionals. I'm your host, Amy Bryson, contributing lead editor of Smart Manufacturing Magazine. Today we'll be talking about the growing importance of time series data, as well as the emerging trends and technologies enabling better data management and storage. And I'm lucky to be joined by two guests today. Evan Kaplan, a friend of our show, is CEO of Influx Data. He is a passionate entrepreneur and technology leader with nearly 25 years of experience in the CEO role. Evan's career spans from creating startups in his own garage to leading NASDAQ-listed companies generating nearly $200 million in annual revenue. And joining Evan is Rick Bellotta. Now, Rick was CTO and co-founder of the world's first platform for creating connected IoT applications, ThingWorx, which was acquired by PTC in 2013. And since then, Rick has been an active mentor, advisor, and an investor in areas including robotics, AI, and digital and additive manufacturing. He's also a recognized expert on IoT and advanced manufacturing, having served in roles across like plant operations, sales, product marketing, systems integration, and technology. And word has it, he plays a mean cowbell. I want to welcome Evan and Rick to the show.
Hi, Amy.
Hey, Andy, thanks for having us.
Wonderful. So before we jump into our discussion, can you each give our listeners just a bit more background about each of you? And I'd like to start with Evan, if I could.
Yeah, sure. I'm the CEO of Influx Data. So we've been the leader in the time series data market, pioneered the modern time series data area. I've been doing this a really long time across a variety of technologies, primarily networking and security, but for the last 8 years in data. I'm based in California.
Sure. So my background's kind of been in and around all aspects of industrial software. And when I say industrial, it'd be manufacturing, energy, related transportation, things like that. But I think one of the things that's helped me quite a bit is having been a user in the plant floor, having been a systems integrator, trying to piece all these Lego blocks together to solve customer problems as a vendor, and then more recently as kind of an advisor both to startups that I work with, some young folks that I mentor, but also as part of an advisory board for the Smart Manufacturing Executive Council, which is made up of about 30 of the leading manufacturing companies in the United States, and really trying to evangelize and spread best practices around advanced manufacturing, intelligent manufacturing. So keeps me busy these days.
Yeah, that's great information for our listeners to check out more details about the Smart Manufacturing Executive Council. I know we work a lot with SESME ourselves, and our listeners are made up largely of small and mid-sized manufacturers who are really themselves grappling with, smoothing out or simplifying the complexity of smart manufacturing. So your insights and expertise will be really welcome information for them today, for sure.
We should highlight that Rick is actually an advisor for Influx. I've known Rick for 6 years, and he's been a tremendous asset for us. And everything I know about data and manufacturing comes from Rick, so anything on time series, I'm going to be comfortable with. Anything in manufacturing, I'll probably defer to Rick.
All right, wonderful. It'll be a wonderful tennis match today. Rick, let's get your perspectives on maybe what are some of the most significant trends shaping the IIoT landscape today.
I mean, certainly the macro trend that no one can miss broadly is the influence of AI and machine learning, kind of taking these massive amounts of data we've been collecting and doing something useful with it. Another thing that's probably, it's been around for a while, it's certainly under the spotlight again, is how to effectively use edge and cloud compute together to solve these problems. We're starting to see more a realization that 20 years ago, we were collecting massive amounts of information like a temperature sensor, the status of a machine. Now that data is getting increasingly rich across many sources and streams, needs to be contextualized. And that's really to enable what we want to do with AI and machine learning. And probably the other interesting one is I'm starting to see more data sharing across value chains. People that provide production equipment want to know how it's actually working in the customer's factory. People that make components for another manufacturer share that quality and performance information. So this cross-business data sharing is starting to become more of a mainstream activity.
I think just to ride on the back of what Rick's saying, having just coming back about a month ago from a week in Europe, visiting Bosch and Siemens and a variety of other industrial concerns. I think Rick is right on. The key for lots of these folks, whether it's machine data or process data, is this high resolution data. And the high resolution is much more descriptive than it would have been 10 or 20 years ago. Higher cardinality data, handling that data, building an intelligence framework. So we're seeing lots of folks build data architectures now that include lakehouses that they're using as intelligence workbenches, places that they're building their training and inference models, and then reapplying it back to the edge, to the manufacturing floor, to that sort of stuff. I think the key here that I think both Rick and I probably agree on, although I should say that carefully, is that it's really about high resolution data. The ability to collect so many variables associated with a timestamp measurement really can describe almost completely a process that would have been really difficult to do 15 years ago, 10 years ago, even with the standard manufacturing execution systems and the other tools. I don't know, Rick, you agree? Or
Absolutely. And then, as I said, the fidelity, the richness, pulling it across multiple sources. I think another kind of subtle but important change is going back, as I said, spin the clock back, we were focused so much on asset data, so sensors from our physical assets. Increasingly, it's not just from assets, but from the processes that we do, the work tests around making stuff, servicing stuff, whatever. That's a whole nother data exhaust that we're capturing now. And kind of, again, synthesizing those two together is where a lot of the real value is being captured.
Yeah, in some ways, I mean, Rick, in some ways, the asset data is like, 101, and process data is just so much more difficult. It's like, advanced 400 series of taking the course.
I think that's a fair assessment.
Yeah, I wonder if you could each share some examples of what's possible now with time series data, that has evolved, let's say, over the past 5 years. What's possible now that wasn't possible a few years ago, so our listeners can put some kind of paint on the canvas for problems that they might be trying to solve right now?
Sure, I'll take a go. I mean, one of the companies I work with, a company called TwinThread, does they're basically automated AI and machine learning for manufacturers. But what the ability to get time series data from different sources, from our manufacturing execution systems, from our process automation systems, even things you wouldn't necessarily think influence performance, weather. You'd be shocked how much that influences the nature of many industrial processes. But anyway, bringing all these streams together, being able to contextualize them, then apply, advanced algorithms, not in a way that requires data scientists, right? So we have to be able to get all this data. We have to be able to query it in the way we need it to be able to do analytics, to normalize the data from all those different streams. So, InfluxDB provides that kind of unifying layer once we've got it in that repository to pull all that information out and do what we need to it. But now increasingly, we're starting to see people use that data, learn and train very advanced models, and then close the loop on those models, run them in real time, and literally in real time, changing settings on equipment to optimize product quality or energy consumption or something like that. So we've moved from kind of visualization to reporting to closing the loop. And that doesn't always require AI by any stretch. It's just that I think the spectrum from kind of insight to action is becoming much, much more closed loop and near real time. Instead of those reports we'd print, and look at them. I couldn't call them the "we sucked yesterday" charts.
I'm not heard it called that. It's I think there's and this is where a big part of our business is industrial IoT, but a lot of it is in financial trading, network telemetry, consumer IoT, stuff like that. And I think the narrative is in some ways very, very homogenous, which is any human design system, and manufacturing is just a perfect example of it. Any human design system over time, if it's anti-entropic at least, it wants to be self-healing, self-correcting, and eventually autonomous. And so those journeys, I would say we were stuck for a long period of time, and Rick, you can disagree or not, but we're stuck in this notion of real-time monitoring as the end-all and be-all, which is, hey, we're looking at dashboards, we're looking at our systems, we're looking at what Rick just said beautifully well, is yesterday we sucked kind of model. And what we're seeing is AI, machine learning is doing part of it, but much more sophisticated data collection, processing is doing a big part of it. Is you're on a journey towards real-time monitoring and control, not just monitoring. And, in aerospace, we would call that indication and control. What's happening in the system and how do you build the control loops? And I think the thing that we'll see over the next 10 years, although I don't think we're seeing much of it now, we're seeing some of it, is actually increasing autonomy in these systems, which is really the grail that everybody. And so in order to do that well, almost everything has to be real time. Almost everything. The data collection and the ingestion has to be elite. The querying capability has to be as close to real time as possible. So sticking it in queues to process it later becomes less and less effective when you're building control loops. These things are all fine when you're building monitoring loops, but when you're building control loops, everything changes. And that's what we see a lot of people trying to get to. I would say we're very early in that cycle. I think we're very early in the cycle of building meaningful intelligence. And I think we're really early in the cycle in building really effective control loops. But it's all there. And so I wish we could fast forward this 5-10 years. We'll be ogling over the kind of things people are doing.
Okay, well, let's mark our calendars for 5 years from today.
Hopefully I'm on my bicycle and not talking to you. No offense.
Well, by then you can do both seamlessly. So let's talk a little bit about edge data management and storage. With the exponential growth of data from IoT devices, from your perspective, what are some of the emerging trends in data management and storage solutions?
I'll take a crack first. I would venture a guess that the vast majority of that data has been collected in the industrial world, not necessarily in network telemetry and things like that. At the edge, 99.98% for many, many, many years. Then there was sort of a lift and shift where just for manageability, people, we jokingly called it pie in the sky. Bringing their OSI salt servers up to some managed data center or whatever. But I think for so many of the folks in our world use that historical data, or at least the near-term historical data, the past 30 minutes, 8 hours, 24 hours, as for real-time operational support, that it's basically mission critical. So for a variety of reasons, latency, performance, availability, those workloads are still going to run at the edge. Also, when closed loop AI or machine learning algorithms require some historical data to do their scoring, again, that's we're seeing a macro trend to do train in the cloud, execute at the edge. But for long-term storage, where we're going to train these models, where we're going to do experimental analytics, where we're going to share that data in detail or in aggregate with their value chain, that's kind of where we're lifting and shifting it to the cloud. I think the challenge remains if it's still this big impedance mismatch between the systems we use at the edge and the systems we're using in the cloud. It's created a whole cottage industry for companies that glue that stuff together. And then the other real reality is while edge is almost always hot data or relatively warm data, in the cloud we also have a use case for cold data, for long-term archival, for compliance reasons, or a variety of different. So it's kind of like, okay, what's the right case? Where do we do it for availability, latency, and cost? And then where do we do it based on what we're trying to do with the data, the need for retention, I think integrators and users and ISVs are becoming kind of increasingly literate about what to do where. But, there's still work to be done to make the easy button so that your edge just publishes to the cloud in the, fully contextualized across multiple sites. We're getting there, but there's still work to be done.
Yeah, I don't have much to add there, except the one of the key issues at the edge are latency. Obviously, you're going to get a better performance when you're making these decisions at the edge. You want to push intelligence down to the edge, not just data collections. If you're going to build meaningful control systems, they literally have to be on the edge. So they're what we would call the edge. Control systems out of the cloud are a very different category of thing, and I don't think control systems on the manufacturer are ever going to operate out of the cloud in a meaningful way. But I agree with Rick. It's, most of the intelligence, all the model building, all that stuff will be built on cloud models, and most of that data will originate at the edge.
So, Evan, let's talk a little bit about some of the recent technological advancements that are impacting IIoT analytics and operations.
So I think, we covered it somewhat in the question before, that it's not, I don't think the impact is tremendous at this moment, but it's not far off, as everything to do with machine learning and AI is, is basically taking the telemetry data that's coming off of whatever system humans have built and saying what happened, what's likely to happen, what's going to happen, what's the canonical example, that is a self-driving car. And so from the data point of view, what has to happen to make that work? All those things work. So as we've already discussed, you have to have something at the edge to handle latency, security, and the way these things operate. Two is you have to be able to collect high resolution data. So you have to be able to handle cardinality, which is really the blocker of collecting really, really high resolution data. You have to have relatively cheap sensors and available, and that's already happening in meaningful ways. Right? You generally want to have a relationship with a different storage mechanism as opposed to in-memory storage. You want object storage and things like that. And then you want really clear integration with wherever the intelligence of the training models are going to be built, so that so the models themselves are not static. So they're updated on a regular basis. They become part of that continuous loop. So there are some really important open standards that have emerged around this. Obviously, object storage is a relatively open standard. Parquet file formats, Iceberg tables, open tables, so there's a query. So a bunch of that stuff that removes the impedance and friction around that. But, perhaps the most important thing is not actually a technology change. And I'd love Rick to opine on this effort, which is I don't think it's a make versus buy decision about what you're doing in the industrial world the way it was, 15, 20 years ago. You'd select your vendor for an execution system or different stuff. I think you're seeing a much more sophisticated, I don't want to call it IT because that means something else. You're seeing a much more sophisticated data people on the factory floor. I'd argue that increasingly they're more development capable as opposed to configuration capable. They know how to build the systems. They have some more data science backgrounds. You're seeing that slowly but surely strip into this. And I think you're moving away from this, I'm buying this big giant platform that's going to do everything. I'm going to have this long-term vendor relationship. At least that's our view because we're that disruptive force. But Rick will probably say, Evan, you're crazy. This stuff is entrenched for the next 30 years.
No, I mean, I agree wholeheartedly that we've got probably, we're just seeing the first pure digital age workforce coming into manufacturing, right? That grew up in an environment where the internet was pervasive, where mobile devices were pervasive, where ready access to essentially the entire world's information. I mean, imagine, a few years from now, kids that have grown up with, AI agents around them, how they're going to do their work tests so differently. So no doubt, that's a major influence. Second thing is we've got a workforce, not necessarily the shop floor workers themselves, but the folks that were traditionally manufacturing engineering, process engineering, more comfortable with, DIY and a little bit of coding and scripting and things like that. Whereas a few years ago, it was more like, we'll live within the limitations of what this package software does. And then, pure technologically, storage approaches zero. Every year it costs us, it's storage is nothing now. But you look at what's happening with things like Spark and Snowflake and Influx 3, leveraging compute to do more interesting things with the data, right? So you're no longer restricted by one big monolithic piece of software. You can scale out and use compute power to ask questions that would have been, you would have had to go get 2 cups of coffee and come back and maybe the answer would be there. So that's the ability to do more advanced things in very near real time is a byproduct of that kind of technological change.
Great. So let's talk about things that you're seeing where manufacturers are doing things, well and reaping the benefits of some of the things we're talking about. And what hurdles or roadblocks are you still seeing that should be addressed and can be addressed, right now?
I think one of the more interesting things, and maybe I'm biased by recency effect, is, I'm seeing older equipment being updated with Linux-based PLCs that people are learning how to use, the things that would, that really has an asset life for 40 years and should have an asset. They're big machines and that sort of stuff. You're seeing this next generation of folks saying we can outfit this stuff and we can bring this as part of an automated factory model. I think that particular thing is, and I'm biased by the recency effect, I think that's actually a really interesting dynamic. So we're seeing them comfortable building these Linux-based things, operating at that level to automate things that, would have never been automated before.
So I think one of the big things is while there are definitely, particularly in the small to mid-sized manufacturer segment, not enough investment or access to the data they need, that's somewhat a byproduct of the vendors that service those industries. It bothers me to no end how much OEM equipment that gets installed in a factory is closed, and you can't, they either charge you or it's difficult to get at that data. I, as a customer or an integrator nowadays, they need to use their voice and their purchasing power to demand, systems that have open access to data. But let's assume we can solve that problem. There's probably also still too much that there's like a inertia or gravity that's needed that only the Fortune 1000 companies have typically adopted some of the more advanced technology. So I know that's one of the things that SESME and others are trying to do is democratize, to share those best practices, which is not always about technology. The other one that's a big passion for me is the ones that are doing it right, or the ones that include their frontline operators in the equation, both as, quite frankly, as an extraordinary source of information and insight. But if we're going to put this technology in, let's give them superpowers with it, right? It's just like the same way we want to use robotics to, augment unsafe or difficult or challenging tasks. Let's view it not as this big brother-ish type tool. Let's include them in the loop and include them in, designing the user experiences and the applications, and recognize that for a long time to come, humans, all AI in the world, humans are still going to be the decision maker and actuator in a lot of factories. So the smart ones are realizing that. And I think by, again, going back to the fact that we have this digitally literate workforce coming in, if I go from that, if that's my world outside of work, and then I come in and I'm, I've got a knob that I turn and a button that I push, that's not going to be intellectually stimulating or challenging. Hiring and retaining people in these roles is going to be increasingly difficult. So seeing technology as a tool for all of the folks in the enterprise, I think, is important.
Yeah, it's an interesting point about the talent struggles that a lot of industries are facing right now, but certainly manufacturing, and that juxtaposition of, older experienced workers leaving the workforce and, trying to attract younger generations that have these native digital skills, and manufacturing kind of catching up and redefining some of the roles and not just jobs, but career paths, which from my perspective, I'm talking to really smart people like the two of you and others, it's like such an exciting time to be involved in manufacturing from a career perspective. And I think shining a light on some of those opportunities in the next several years, hopefully will, allow small, mid, and large manufacturers to really move the needle on deploying smart manufacturing technologies, processes, and getting the talent challenge solved a little bit.
Yep, and I'm hopeful that the other part that happens with that, again, by giving them digital tools. Let's face it, at the end of the day, it's the soft things that are going to matter just as much. Mm-hmm. Fair wage, flexible work schedules, respect, the things that humans value.
Meaningful work, yeah.
Exactly. But my question and my challenge to the ecosystem has always been, can we use technology to mitigate some of those issues? So, for example, if we can use technology to become more productive and pay higher wages because it's a higher skill set, if we can use technology and knowledge sharing to make folks more interchangeable in different jobs in the facility, can that free up flexibility so you can take half a day off and go see your kid's football game or whatever? Those are the kinds of things. I love to challenge the community to think differently about how we're applying these things to deal with what really aren't technological problems.
I think so Rick touched on the social political side of it. I think I feel, despite our current political environment, I feel super optimistic about, one is the clearly strategic demand for nearshoring and onshoring manufacturing. So you have that dynamic, I think, is likely to play out both in high-tech manufacturing, discrete and process manufacturing, more so here in the U.S., North America. So you have that dynamic. I think then if you take that along with the digital natives entering the workforce in a meaningful way and the big advancements in AI, I think we're set for a bloom here. I don't think I'm being overly optimistic. We're set for a unique reset bloom of, at least North American-based manufacturing. It's hard for me. I don't have a real good view. I know how powerful the Chinese manufacturing is, but I just don't have a really good view into that world because it's very hard for us to do a lot of commercial work there versus in the U.S. and Europe, to where all of our customers are.
All right, let's switch gears just a little bit and let's talk about some market trends and the future outlook. I'd love to start with you, Evan. How do you envision the role of time series data evolving in the next 5 to 10 years, let's say, within the industrial sector?
So, in order to talk about the future, step back a couple of years. So, really, the way things have worked is time series has been an integral part of the industrial sector for since there's been an industrial sector and since there's been a computer and even probably before. And 20 years ago, 25 years ago, people were doing this on Oracle and Formex databases, maybe IBM DB2. 10, 15 years ago, they started to do it on MySQL, Postgres, or general purpose databases. It's only in the last 6 or 7 years that you started to see the advent of this very specific, the whole database market breaking up into categories of graph, document, time series, stuff like that. But it's only in the last 15 years, in the last few years, 6 years or so, that you've seen the emergence of time series as a discrete. And so for most people, that's probably not necessary. It probably wasn't necessary. Using a general purpose database was fine. You had experience with it. But as you collect more and more data and you automate more and more systems, the time series becomes the emergent category. It is the instrumentation layer for virtually all intelligence. Really, virtually all intelligence. So you build any system to make it smarter. You start with instrumenting it to see how it behaves. You make changes, you adjust for the changes, you do that 4 billion times, you have a self-driving car. But the instrumentation stays the same as what happened, at what time, under what conditions. And so that to me is all time series. So obviously, but you're talking to the crowd. I'm supposed to be bullish. I'm a CEO of a time series company. But I actually think, fundamentally us or our competitors, that's in fact what's happening.
I'll put the pragmatist spin on the. I think you actually even touched on it, the importance of, kind of polyglot data storage. There's perfectly good reasons where we need to store, textual data and when we need structured data. Metadata is an increasingly important piece of the equation. So I think it's an and not or problem. I use that term a lot, but synthesizing what we have in our time series data is with models of her facilities, the meta models around, what you call them, digital twins, or I don't care what you call them, but that the intersection of those two, I think is kind of super important. I think we're going to see, I hope we'll see more kind of fundamental types of advanced analytics built into the databases instead of side by side. So things like anomaly detection, detecting correlations, cause and effect. In the time series world, I think it's a natural expectation that those will actually become part of the database, not a side-by-side thing. And the choices, the Lego blocks that integrators and customers have to build with have never been better. They've never been more cost-effective. So the other dynamic is cost doesn't go up in our world, right? It goes down, or we infuse more capability into it. So, I just think that the tools and technologies are just going to get better and better. And it's kind of silly nowadays to, why someone would go build certain things that you can buy and assemble together, right? A time series data store being a great example of that. So that, I guess the related question is where it's going to be people doing vertical value add, doing the advanced domain-specific analytics, building platforms and tools on top of all this. I mean, one area that I will say is also a gap today with most of the time series data stores, which is something that the old school historians did fairly well, is a very purpose-built user experience for that non-technical user to interact with that data. And we're seeing, even in the Influx ecosystem, there's ISV partners that have already closed that gap and have solutions. But look, that user experience and then that experimentation, so letting a non-technical user start to run some create some machine learning models or run some AI models and things like that. And then the last piece, if we think of time series data has gone from simple singular asset sensor values to more structured event type data coming out of systems and processes. A natural evolution of that, and I'm seeing massive innovations in this area, is where imagery, non-traditional types of data are time series as well. The thermal profile of that part as it moves through the furnace, a series of images that's a video of a movement of a person or a robot or a automated, AMR type device. That's just as interesting, and the analytics we can do on that is going to be super valuable. So maybe it's going to be an expansion of what the definition of time series data is.
So I feel like Rick should do a mic drop on that. For me, I feel like we should switch jobs. I think if you're going to, so there's a big meta dynamic here. I think we're moving way more into a builder's world than we had. Is it people who know how to build systems, who are oriented around systems technology, right? Who have some data background. We're going to be uniquely advantaged here. And I think that's where Rick was talking about. The digital natives are more likely to have that ability. Certainly going through school, you're more likely to have that ability. My kids certainly see more of that than I do. And I think, I'm just super excited about it. Independent of time series or any data store, like that builder mentality is going to drive this next generation of manufacturing.
Well, those are wonderful insights. And I think the two of you are a really good example of bringing such a wealth of expertise and a view of, what's possible for the future in terms of startups and innovators in the space and how that can come together to not only democratize smart manufacturing for the small and mid-sized manufacturers, but really create a much more competitive, resilient USA manufacturing landscape. So we've covered a lot of ground today, gentlemen. We could certainly talk for a few more days, but I want to be mindful of your time. Is there anything else that you think is important for our listeners to know on the topic?
I think you've got a good, broad overview. Rick, I'm coming at it from a systems perspective. Rick comes at it from a really strong, really well-grounded manufacturing and all kinds of perspective. I think it's kind of a valuable combination. So thanks for having us both together.
I would add, I think that, don't underestimate the importance of people in this whole thing. And it's not just the frontline workers, it's everyone that's involved. There's just so much knowledge and experience. Don't forget what's happened in the past. Let's build on it, not keep reinventing it. I see so many startups kind of wasting capital, energy, brain power, redoing stuff that Lego blocks already exist for that. Let's start focusing on the value added stuff around that. And I think the certainty is that every year this stuff's going to get easier and easier and cheaper, but you have to start. I encourage every manufacturer to just start. pick something, go with it, get your data infrastructure in. I use it to solve, some known problems. There's just the friction's never been lower.
And if people want to learn more about the work you're doing, where should they go? Evan?
Clearly for me, it's go to www.influxdata. And, a ton of resources and material and that sort of stuff.
You can follow me on LinkedIn, but just be prepared to be provoked and occasionally offended. So
provoked and offended. Fantastic. Well, Evan and Rick, I want to thank you for taking time to join us today and sharing your valuable insights with our listeners. And I'd like to thank our listeners for tuning in. Make sure to stay up to date about what's happening in advanced and smart manufacturing and hear more podcasts by visiting us at advancedmanufacturing.org. Take care, everybody.